Hey guys, you on Quadratic Functions Part 4. This is a revision and this is the crash course. All types of transformations and vertex form. So this is exam style question. This is the problem 2. So make sure you watch the previous video dedicated to problem 1. Here is the solution. If you didn't solve that, please go back because it's real significant one. There are lots of details. However, it's pretty short for the full explanation here. Alright, so also we need to solve another problem, which is, it seems to me it's quite definitely hard math for iGCSE and iGCSE extended. So let's get started. Grab your pens, grab your notes. First, try to do by your own and let's get started. Okay, so we have several parts. However, I'll raise the bottom part because otherwise I won't have any space to do that. So first of all, we are going to take those 3 questions related to the function. We have 3 functions, fx, gx, and kx. Have a look at which form they are stated. They have standard form. Write down the y-intercept for each function. Alright, let's answer the first question. And what we're going to do for question in part A, we need to find y-intercept. Remember, y-intercept is when x is 0, so because your parabola actually cross the y-axis, and here is exactly x is 0, alright? So I just put more clearly. So x is 0, in this case, we just put 0 everywhere, and f from 0 will give us +1. G from 0 will give us 5, and the last one, k from 0, will give us 0. Another way you can do that, let's have a look at the coefficient c. Coefficient c is actually y-intercept, so here is 1, here is 5, and here is 0, so you can have a little shortcut and do it very fast. Let's go to the question B. So in question B, you need to determine which function or functions has or have 2 x-intercepts and what are their values, okay? So you need to define x-intercept, and as you remember, for x-intercept, we're saying that the resultant function y generally should be 0. So that's why we equate each, so we convert the equation of the function into quadratic equations, and we need to solve. Okay, so let's write them. 3x squared minus 2x plus 1 equals to 0. That's the first one. This is for f from x. So next one, g from x, will give us -2x squared. I just rewrite in standard form right now. And plus x, next goes x term, and plus 5. We also equate to 0. And the last one, for k from x, we get x squared plus 2x also equal to 0. I start from function k because it's much easier to factorize, and we'll have 2 factors, x and x plus 2, from where x1 is 0 and x2 is -2. So that means it has 2 intercepts, alright? So that's why definitely the function k. So we can state that k function definitely, k from x, 2 intercepts, 2x intercept, and we also know 0 and -2. So next one, let's do g. So we have -2x squared plus x. I multiply by -1 so that to get proper leading coefficient, so 2x squared minus x and minus 5. That's much more convenient. So just multiply by -1. And now what I'm going to do, 5 and 1, I'm going to use discriminants, so quadratic formula. So x1, x2 is minus b, so 1 plus minus square root of discriminant is -1 squared is, I just write, okay, -1 squared, and plus 4 times 5 and times 2. So I write plus finally, because minus by minus is plus. So 4 times 5 and times 2. So that's what I'm going to have right now. And over 2a, which is 4. Okay, so that's why I'll have 1 plus minus, let's take 1 plus 4 times 5 is 20, okay, and I've got 40 in total and 41, so square root of 41. I leave thirds, but if you like you can use calculator and calculate, so that's why it also has 2 intercepts, so that's why I put also the function g, right, in this case this is g from x. And finally, let's try to solve this. So again, I'm going to use discriminant. First of all, I just estimate. So b squared minus 4 is c, works like this. So what I'm going to do, I'm going to estimate discriminant right now. And it's simply 4 and minus 12. So what I've got negative, and if you know that if discriminant has a negative sign, it means what? It means that no x-intercepts. So you need to write that no x-intercepts. Okay? Why? Because you cannot figure out the x value, and that means your graph is completely below or above x-axis. So I can show you quick. That's real quick, and let's drop. So let's say in our case we have leading coefficient 3. It means that our parabola with y-intercept to be 1, and goes something like this. Okay, no x-intercept, that's typical graph. Okay, so which function has no x-intercept? So that means fx. How it can be deduced? We just recently used the discriminant to estimate the value for it, and it means that we cannot take the square root of negative 8, so 8 doesn't exist. All right, let's move to the second part of the questions. I hope it's pretty clear. Have a print screen, and let's go next. So here what we're gonna do. We need to make vertex form for gx and kx. All right, so we have gx and kx. Let's start from kx because it's much easier. So for kx, k from x, we have x squared plus 2x and plus 0. Okay, I just remind you that generally the vertex form is the form ax minus h squared and plus k, where h and k are coordinates for the vertex, so h and k. So they are coordinates for the vertex, okay? This is the vertex. All right, now how to do or how to accomplish this form. So it's based on completing the square, and what I'm gonna do, I'm just use the formula let's say plus a squared plus 2ab and plus b squared. So I have this part, which actually is going to be a plus b squared. So what I have right now, I have x squared plus 2x. So if I add 1 and I immediately subtract 1, I'll get the complete square right there. You can check. So that's why this is going to be x plus 1 squared and minus 1. So I immediately arrived to that. Okay, so that's why that's the kx vertex form. So this is the vertex form. Okay, next one. Let's take another function, g. So first of all, I just rewrite in the form gx in the form first negative. What I'm gonna do, I'll just try to demonstrate another way, because completing a square is quite, it's quite complicated for this stuff. So that's why what I'm gonna do, I first rewrite in standard form normally, and now I'm gonna use the general structure. like this, ax minus h squared. So I will use the general form. So x minus h squared and plus k. Okay, so what I'm going to do right now, I'm going to expand these brackets, and I'll say that according to the formula, I'll have x squared minus 2hx and plus h squared will be equal to, n plus k. Okay, now what I'm going to do, I'm going to compare coefficients. So have a look here. So if I expand, I will have x squared. However, here in the original one, I have negative 2x squared. So that's why, by comparison, a is simply negative 2. Okay, so I fixed a, and now I need to define the h value. So that's why, for this reason, I'll put negative 2 everywhere, and I rewrite as the following. Negative 2x squared, then negative 2 times negative 2hx will give me 4hx, and negative 2 times h squared is going to be negative 2h squared, and finally I add k in the end. So guys, let's have a look and let's make a comparison. 4h is the coefficient before x. What I have here, I have 1. So that's why 4h is going to be 1. Okay, this is made again by comparison. So this is 1. So if 1 equals to 4h, I can figure out that h value is simply 1 over 4. Or if you like, 0.25. So now I know it's 0.25. Right now, I just can calculate the last part, which is in our case is 5. This is the last coefficient. So I'm going to solve the last equation here, which is negative 2h squared plus k equals 5. But instead of h, I will use 0.25, or as you like, 1 over 4. Okay, so I'll grab 1 over 4, and I'll write that negative 2 times h squared is 1 over 4 squared is 1 over 16, and plus k will be equal to 5. Okay, so what I'm going to do right now, just express k, make k as the subject. So k from here is simply 5 plus, and negative 2 times 1 over 16 is going to be negative 1 over 8 here, but I transfer to the right side, and I'll get 1 over 8 in total. So that's my k value, which is 5 and 1 over 8. So k here is 5 and 1 over 8. If you calculate, it's 125. So that's my k value. And now what I'm going to do, I'm just circle all the values that I found. So k, h, and a. Okay, now I know all the values, and from here I can plug them into the equation. So that's why my general equation for g function is going to be using coefficient. So where to write? So right here. So general form is going to be g from x. Sorry, not the general, but vertex form. So it's a, which is negative 2. I will multiply by x minus h, so x minus 0.25, which is squared, and on top of that I add k, which is 5.125. Okay, so that's also the final equation for vertex form for g. So just change the color, which will be more appropriate. So this is g from x, and for k was pretty easy. So k form for the vertex is simply this one. So k from x is x plus 1 squared minus 1. Okay, and I also circle it. So that's both vertex form. Now state the vertices for the function. All right, so what I'm going to do, I'm going to state the vertices for the function. So for g from x, I'll have negative 0.25, so it's going to be positive, so h vertex is 0.25 and k value is 125. So that's why that's the x coordinate of the vertex and this k coordinate of the vertex. For the function k from x, you also can get 1, but because it's plus 1, but in the formula, if we apply the vertex form, it's minus h, so h is negative 1, so we can write h is negative 1, and k value is negative 1 as well. So k value is negative 1. So for f from x, guys, please do by your own, please do by your own. Okay. And describe the transformation that make function kx be y from x. So in other words, what we're going to say, that we need to describe which transformation or transformations occurred during converting kx, so we need to understand how k from x becomes y from x. For this reason, it's much more convenient to use vertex form, so you can grab from here and from there. So k from x is simply x plus 1, so x plus 1 squared and minus 1. So y from x, now let's write, be y from x. I think that's misprint, so it's going to be g from x. Yeah, we don't have y, so g from x. Sorry, my bad, and I didn't see this misprint. So, and the final g form for our function is negative 2. So it's negative 2 x minus 0.25 squared plus 125. Okay, so that's the target. So this function is the target. Okay, so now we don't need any other stuff except for what we have right now. And let's try to convert. The way I do is the most efficient way as I compare with other ways. So what I'm going to do, I'm going to take our kx, and first we need to have negative 2 before a bracket. So what I'm going to do, I just simply times k by 2. So 2k from x is going to be, by negative 2, because we need to have negative 2. We'll get negative 2. Right side is also multiplied by negative 2. So we've got this and plus 2. Okay, we multiplied the right side also by k. Now what we're going to do, we need to have, instead of x plus 1, negative 0.25. So we just simply use another argument. Instead of x, we taken away x, this minus 1, because we need to kill this one, so that we'll stay with x inside. And now we also subtract 0.25 as well, okay? So in general, so let's have a look what it will happen after that. So we have a look at this argument, and we saying that x, instead of x, we plug in x minus 1 and minus 0.25. We will exactly arrive to x minus 0.25 squared. And right now until now we have still plus 2. So in other words, we can say that we simply take away the argument 125, okay? And that's how we get this part. So it's negative 2 x minus 0.25 squared and plus 2. And the last thing what we need to do, we need to, instead of this, the free coefficient, make 125. So what we can do, we can add to both parts 125. Yes? So we need to add 3 125. So how it's possible? That's pretty easy. We just simply need to add to both sides this value, and that's why we will get 3 125 on the left side, and on the right side we will have exactly what we supposed to have, the target function with the free coefficient 5 125, in other words the vertex. If you compare, we exactly see that this is the g function, so this is g from x, and left hand side, actually left hand side, it shows you which sort of transformation occurred during our transformation process. So first of all, this is scale. So it's absolutely scale up, absolutely. However, we have negative, so scale up by a factor -2. So that means the function, the branches were flipped over. It means it also you can combine with reflection. So scale up with the factor +2 is better to write, and reflect in x-axis. So next one, -125. So what it means? So that's the first transformation. So the second transformation is here. So that's the second transformation. It's a horizontal translation, okay? By 125 units to the right. And the last step, on top of that, we add 3 125. So that means this is the third transformation. It means it's a vertical translation by 3 125 units up. Okay, up. So actually we've got everything here, and that means that we describe transformation occurred. So that's the complete manual. This is the complete manual, and this is the hardest possible problem that you might encounter. So actually, as you can see, it has several steps. So make sure you understand this, make sure you like that. So please, guys, try to use this as your guidance in this sort of questions. Okay, I'm finalizing, and before I finish, I want to say a few words about Zillion's A-level class. That's my friend. He's very awesome and creating video for A-level. So he's just recently started. I'll also be doing this program soon, because up to request of you guys, because several of my students require definitely have A-level because they're A-level students. So please, you are welcome, guys. Soon I'm going to continue my series. I think it will be still dedicated to mechanics as you asked me. And later on, I switch to other topics that you want to see, okay? Thank you, guys. And make sure you're subscribed to be notified, because I'm trying to create videos and video series on a daily basis. Make sure you watch also the series dedicated to the pick of the week, where I picked out very nice problems. They're sort of, sometimes they're outstanding, sometimes they're sort of like average one, but I like it, and I like to give you a chance to do by round. All right, that was Daniel Dallas. Thank you, guys, and see you later.